Welcome to Chips and Salsa, where we talk security at Intel. I'm Jerry Bryant, and joining me in the studio once again is Anand Pashupathy, VP and General Manager of Intel Product Security and Assurance. Anand, great to see you here again.
Thank you for having me, Jerry.
We have a few topics we're going to cover today, including Intel's engagement with AI models for cybersecurity, where we have a unique perspective, recent confidential computing announcements, and digital sovereignty. Let's jump into it. So in early April, we announced Intel's participation in Anthropic's Project Glasswing, and later we joined OpenAI's Trusted Access for Cyber program. And we've seen a lot of news about how many vulnerabilities these models are finding, and customers want to hear more about what are the practical applications of these tools. So what have we done here at Intel? What insights can we share?
Sure. We always knew that there would come a time when LLMs would be used for scanning digital assets that Intel produced. And we wanted to make sure that we do as comprehensive a job as possible. And we also were cognizant about the fact that bad actors would use similar LLMs to attack our products. And the real story behind all of this is it's the application and the systems you need to put in place to deal with the situation at hand, either proactively or reactively. And this is critical for us at Intel because unlike software, applying these techniques to firmware and hardware introduces a far greater complexity and requires a much deeper systems understanding. And we've been investing in AI for security research well before the recent wave of generative AI. And those early investments are now paying dividends, allowing us to rapidly operationalize use of these advanced models and lead in this space. And the key takeaway really is that while AI can surface vulnerabilities, but without context, it just generates substantial noise. And to address this, Intel has developed a structured, multi-stage approach that incorporates system-level context, leverages multiple models, and rigorously filters result. And the outcome is a dramatic reduction in false positive, and in some optimized scenarios with proper context, we have achieved true positive rates of up to 50%, which is outstanding in the world that we operate in.
So let's talk now about confidential computing and some recent announcements made by Microsoft and Apple. What's the news there?
Two completely different applications of confidential computing. One is more at the infrastructure level. So what Microsoft recently demonstrated and announced is that they're working on confidential live migration in Azure built on Intel TDX. This is a significant step forward for confidential computing technology. So imagine the scenario that they currently operate in where non-confidential workloads are moved around in the fleet. Now they have demonstrated the ability to do the same thing with confidential workloads as well. It's the first demonstration of such capability running in Azure on Intel TDX, actually across any other hyperscaler, because it really enables secure movement of confidential VMs to other systems, and it allows for trade-off between strong security and flexibility, because the hyperscalers, they jam as many workloads as they can as a Tetris model. And this marks a meaningful step forward for real-world adoption of confidential computing powered by Intel TDX. So that's at a very foundational level. What Apple announced is they're pushing the industry forward by extending their private cloud compute architecture into third-party clouds and proving that strong privacy guarantees for AI can scale beyond just a single vendor's infrastructure. And their approach reinforces the importance of full-stack verifiable security, no privileged access, transparent operation, and protection built across every layer. And notably, these deployments rely on Intel CPUs with TDX, underscoring that hardware-based isolation is foundational to trusted AI. This is a clear validation of our strategy that Intel TDX is not just a capability, but a critical enabler for confidential computing at scale, and a signal that we have the opportunity to lead as an enterprise demand gets stronger. Provable protections for AI workloads are available everywhere. And I want to also do a shout out to our partners at Google Cloud that have worked very closely with us to enable this for Apple.
Awesome. And I think that's a great segue into this next topic of digital sovereignty and how Intel provides the foundation for customers to control their data no matter where they're processing it. So to start, everyone seems to define digital sovereignty or sovereignty differently. How should we think about it?
Yeah, but you're right. Definitions vary, but at its core, digital sovereignty isn't just about where your data resides. It's about who controls it and where that control, and can you cryptographically prove that control? And when you think about it across 4 dimensions, you have data sovereignty, which is jurisdiction and access. You have technology sovereignty, trust across the full stack, hardware, software, networks, and operations. Operational sovereignty, which is prove where it runs and govern it independently. And lastly, assurance that it's built on the partner's proven security track record. Different regions emphasize different aspects, but they all ask the same question: who controls the system and can you prove it?
So the idea of proof seems very critical. So what's missing today in common solutions?
Yeah, when sovereignty started becoming a big deal, those claims rested on contracts, policies, or vendor trust. But customers, especially governments and regulated industries, want runtime proof that controls actually work. And assurances aren't enough. They want verifiable evidence. That gap between policy promises and provable enforcement is what real sovereignty has to close.
So you've framed this around a couple of dimensions of trust. Can you walk us through that?
Yeah, and as you said, there are really these 2 dimensions of trust. There is the human trust, which is the belief in intent, subjective, it's relational, it's earned over time. Intel has spent decades building it. Then there is computational trust, which is the proof of behavior, cryptographic evidence that systems work as projected or as expected, and independent of the operator operating the system. Customers need both. They need the trust in Intel as a partner and the technology to build their own provable trust to their customers.
So why is the hardware root so important in these scenarios?
Yeah. We are a hardware company, so we obviously talk about hardware as a root of trust. There is another reason for that, because software alone cannot establish sovereignty. If your root of trust sits above the hypervisor, i.e. depends on the software stack, you're ultimately trusting the people who are administrating it or the providers that are deploying the system. To us at Intel, true sovereignty starts in silicon, below all of that. A hardware-anchored root lets you measure the system from power on, enforce controls at the lowest layer, and ensure it behaves as expected. Without it, sovereignty depends on people and policy, but with it, the system enforces it.
So what happens when data is actually being processed, especially with AI?
Yeah. I'm going to give you a little bit of education on data and how people protect data at different stages of its transition. People protect data at rest with encryption. It's necessary. People protect data in transit with TLS and other encryption technology while data is being transmitted. But when data is actually being operated upon, it's in clear text because you cannot operate on encrypted data. And because of this, protecting data, protecting AI during execution is extremely important because that's where data is vulnerable. Confidential computing And now with confidential AI, which is like the merge of confidential computing and AI, closes that gap, keeps data, the models, the input parameters, the output parameters protected even from the infrastructure that they run on. And if you can't enforce trust at runtime, you don't control your AI. You're just hosting it.
But how do customers actually verify all of this on it?
Sure. I think I told you that you need to provide cryptographic proof that the workload ran as the workload was described to run. And at least in the industry parlance, we call this attestation. And attestation provides this cryptographic proofs that the system behaved as expected. Transparency lets customers, regulators, and partners validate that proof independently. And if verification depends on trusting the vendor, it isn't sovereignty. It's delegation. And real sovereignty requires independent verification with cryptographic proof supporting that.
So, what makes Intel's approach different?
We deliver end-to-end chain of computational trust. That's big. And not just isolated features in isolated segments of that end-to-end story. The trust starts in silicon, is enforced at runtime, verified independently, and work across an open ecosystem. That combination is what makes sovereignty provable. It's not just a technology you can use, but a technology you can prove and trust from Intel.
So, final question, what is the ultimate outcome for customers, especially with an Intel solution?
I love this word outcome because at the end of the day, that's why we are in business, because we are trying to deliver positive outcomes for our customers. And the outcome is really moving from compliance to confidence. Controls give you assurance. Only independent verification gives you sovereignty. And Intel provides both the controls to enforce security and the mechanisms to prove it. And sovereignty isn't just policy, it's about provable control. And I would also say confidential computing is becoming this underpinning technology to deliver all kinds of sovereignty, data sovereignty, AI sovereignty, because it's not just rooted in a particular location, but it gives you control and access to data that people need access to, and you have cryptographic proof that's what happened. And that's extremely powerful for this confidential computing industry.
Well, Anand, awesome. Thank you for this update. It's been very informative. If folks want to learn more information, go to intel.com/security. Also, you can find information about confidential computing and other Intel platform security topics in our 2026 Intel Platform Security Report at www.intel.com/security report.
That's great. Jerry, thank you for having me. Pleasure.
Thank you, Anand.